Hello. Today we are going to talk a little bit about deductive and inductive reasoning. In this course thus far, we have been reading essays and considering whether we believe the arguments that are put forth have validity or they do not. Now we're going to learn about a couple different things that you can consider as you are deconstructing essays. So let's start out first by defining deductive reasoning. Deductive reasoning will begin with a general or universal statement. That statement will be used to move on to a specific, more limited one. And I think that it might be easier for you to remember by using an acronym. DOGS. Who doesn't like dogs, right? DOGS, deductive or general to specific. Okay? So that's kind of a way to differentiate. A lot of times deductive reasoning is used to create what is called a syllogism. This is a form of deductive reasoning which is made up of three parts. The major premise, which is the general statement, a minor premise, which takes that general statement and applies it to something specific, and then those two things are used to come to a conclusion. So one thing to keep in mind is that in deductive reasoning, there's got to be an assumption. And assumptions are actually called premises that are used as reasons in deductive reasoning. Okay, a premise, we have a major premise and a minor premise, and then your conclusion. Okay, and you can refer to the example in your book on page 85 if you need further clarification of that. And as stated, deduction is moving from one premise to another to reach a conclusion. The one thing that's obviously important in this is for us to understand that the premises must be true. If the premises aren't true, then, and correspond with reality, then there's obviously an issue with the syllogism or with the deductive reasoning. It becomes faulty. And if one grants the premises, then one must grant the conclusion. So when you're looking at a syllogism, if you look at the major premise and you look at the minor premise and you think, okay, well, both of those things seem correct, then the conclusion then also must be correct. Let's take a look. Let's look at a couple examples. So all men are mortal. There's your major premise. Notice it's general. Joe is a man. Minor premise, very specific. Therefore, Joe is mortal. You see how you're moving from a general statement to a more specific one. Again, Joe is in the 7th grade. Minor premise. All 7th graders must take math. Major premise. John must take math. It doesn't really matter what order it's in. What you see here, though, is that you're moving from a very general statement to reach a specific conclusion. A specific conclusion. So let's take a look and see if, we have some valid arguments here. Okay, first of all, let's just take a look. No reptiles have fur. All snakes are reptiles. No snakes have fur. Okay, you can take a look and think for a few minutes if that seems believable to you. The next one, no healthy food is fattening. All cakes are fattening. No cakes are healthy. Is that a valid claim? Well, let's talk about the first one. No reptiles have fur. That's true. That is true. All snakes are reptiles. That's also true. So it's reasonable then to assume that no snakes have fur. It's reasonable then to assume that no snakes have fur. The next one, no healthy food is fattening. Well, it pretty much depends on how much you eat. Okay, all cakes are fattening. That's not necessarily true. You see here it says in parentheses, angel food cake can be low fat and it's only fattening if you eat too much. This is not valid. The premises aren't true, therefore the conclusion is not true. Let's continue to look at some examples. No lazy people pass exams. Some students pass exams. Some students are not lazy. All horses have hooves. Sambo is a horse. Sambo has hooves. So, no lazy people pass exams. This is false. Some people do. How they do it, we don't know, but they do. Some students pass exams. This is true. Okay, so the minor premise is true. Some students are not lazy. Now, this conclusion cannot be valid. If you look at one of the premises is not true, so it actually negates the whole entire syllogism. All horses have hooves. Absolutely. Sambo is a horse. Okay, we'll take that. And yes, it is a valid argument to say then that Sambo does in fact have hooves. Now, we're going back to definition, so we're going to talk about inductive reasoning. This uses information about observed cases to reach a conclusion. So we are now moving from specific to general. So if it's not dogs, I don't have a fancy acronym, but if it is not dogs, then it has to be inductive. Inductive is individual, it's specific. The word hot has letters. The word a has a letter in it. All words have one or more letters. You notice you deal very specifically with one word and you use that to come to a conclusion about all words. The way that you have to test induction is you have to consider counterexamples. For instance, in the example above, can we think of a word that doesn't have at least one letter in it? The answer is no, we cannot. So we cannot consider a counterexample. So this is a valid example, or this is a valid example of inductive reasoning. Not surprisingly, though, inductive conclusions are not always true because we basically will be able to judge it only in the scope of our knowledge. There may be some knowledge that we're not quite aware of. All right, so let's take a look here. So Pantheon, a Greek myth, has the god Apollo in it. Narcissus and Echo, a Greek myth, has the goddess Aphrodite in it. So what inductive conclusion could you make? Think about that, write it down or keep it in mind. This red marble is round, that blue marble is round, therefore, so the first one, therefore, Greek myths have gods or goddesses, because we see there are two examples of Greek myths, okay, and they both have gods or goddesses in them, so the conclusion that we would make is that, in fact, all of them have gods and goddesses. Now, here's the truth. We don't know that. We have not read every Greek myth that exists, but based on the conclusions, or based on the premises, that's what we're getting. The next one, this red marble is round, that blue marble is round, therefore all marbles are round. And that seems like a pretty safe premise. I've not seen a marble that's not round. One of the reasons that a marble is because it rolls. Things that roll are most obviously round, so that seems to be a pretty safe bet. All right, let's take a look at these ones. First period is 50 minutes long. Second period is 50 minutes long. All classes are 50 minutes long. Well, we can assume that perhaps there would be a period that wasn't, but based on this seems to make sense. There are 5 pennies and a nickel. There are 5 nickels and a dollar. Therefore, all dollars have 5 quarters. This is obviously, a problem. If we take a look, the first one, as far as we know, it's valid. Now, the second one, it very well is invalid. We know it's not true. And this kind of shows the danger of inductive argument. And to take a specific example as an example of all is always a little bit tricky. And this is certainly an example of that. All right, the number 10 has 1 0. The number 200 has 2 zeros. All multiples of 10 have 1 or more zeros. September has 30 days. October has 30 days. All months have 30 days. So, the first example, the number 10 has 1 0, that's true. The number 200 has 2, that's also true. So those are both true premises to come to this valid inductive argument, okay? That is true. We can't think of any example. If you think of any multiple of 10, there will be at least 1 0 in it. The next one, though, we can think about counter examples. Yes, September has 30 days. October Does October have 30 days? It does not. It has 31. So that tells us that all months do not have 30 days. Okay? You have to consider each of the premises and if they're true. No homework is fun. Hunter has homework. His homework is not fun. This cat has no tail. That cat has a tail. Cats can be with or without tails. So the first example is an example of deductive reasoning, right? We are talking about no homework is fun. This is a general statement. Hunter has homework. This is a more specific statement. His homework is not fun. So we've used general to move to specific. This cat has no tail. That cat has a tail, meaning we're going from specific to general. Cats can be with or without tails. That is inductive. Let's determine if these are deductive or inductive. The pecan tree is not edible. The elm tree is not edible. No trees are edible. No cups in the cupboard are new. The purple cup is in my cupboard. This cup is not new. So, the first one is an example of inductive. The pecan tree is not edible. Okay? This is specific. The elm tree is not edible. No trees are edible. We're moving from specific to general. The next one is clearly an example of deductive. No cups in the cupboard are new. All the cups in the cupboard, right? Moving to the purple cup is in the cupboard. That cup is not new. So you're moving from general then to specific. So I basically wanted to just kind of introduce to you the idea of inductive and deductive reasoning. There's a lot more to consider with these two concepts, but you should be able to basically identify the difference between the two. Remember, deductive reasoning is when you are taking a general premise to come to a specific conclusion. However, inductive reasoning is when you are taking a specific premise to come to a general, more encompassing conclusion. Both of these types of reasoning are highly, highly dependent on the validity and truth of all of the different premises involved. And the way to test them is really to kind of, first of all, consider counterexamples and to consider that each of the premises are true. Because if there are counterexamples that can be determined, or if one of the premises is false, then the validity of the argument is obviously not there. Okay, thank you.